Can you hear me?
Yep.
Yes. Excellent. I'm Jilly McCrae. I'm from Microsoft IT, which is now called CSEO. My general area is in the marketing and sales engineering for all the line of business apps. And note that JT, or Jonathan here, likes JT Rose, is from the marketing division, but don't think of him as just as a salesperson. He's not. He's a person that collects everything together about blockchain for Microsoft and addresses that both in a technical way and in a customer way with Microsoft world. So JT Rose, University of Georgia, I'm reading this, I'm sorry. Graduated magna cum laude, University of Georgia. Then went on to University of Virginia Darden School of Business and was the VP for the Darden Tech Club as well as the Impact Venture Fund. Been at Microsoft for about 2 years, 5 months, 6 months now. There we go. And he's younger than I am at Microsoft. When I went looking for a person that could talk blockchain in Microsoft, I got a plethora of responses. And note that it's an organization of 100,000 people doing many different things. But JT turned out to be the one to be up here. So, JT?
Is this thing working? Yes. I'm speaking to this. Okay. Oh, we got to turn it on. How about that? No. Oh, there we go. All right, cool. Thank you for the introduction. My name is JT Rose. I lead marketing for blockchain all up at Microsoft out of the Azure engineering team, the Azure product team. And so, as Jillian said, I've been at Microsoft about 2.5 years. I started out in our IoT business and then had an opportunity about 18 months ago to start looking at the intersection of IoT and blockchain as almost sort of a side project. My team asked me to sort of take a look at what the implications of blockchain were for IoT, and that turned into a 3-month project, a paper, and a full-time gig. I've not looked back since. So I work with the Azure blockchain engineering team, Matt Kerner's organization, and they're the team that thinks about the set of infrastructure and services that Microsoft can bring to bear, not only in Azure, but also in identity, in our common data system through things like Dynamics, through our data products like SQL. What are the set of infrastructure and services that we can bring to bear for organizations, consortiums, these frenemy networks that are trying to build a new class of application, an application where data is being shared across multiple companies. Data and logic, business logic is being shared across multiple companies and across trust boundaries. And so I can walk you through a couple of things today. One, sort of a quick primer on the way we think about blockchain, the way our customers think about it. Two, what our customers have started to do with blockchain in Azure. And three, the set of services that we've started to introduce to make it easier for customers to work with blockchain using Azure. I'm sure Chris did a great job, as he always does, introducing blockchain, so I won't belabor this point. But I think while initially the cryptocurrencies as a use case popularized blockchain, when enterprises started to get interested was with the advent of Ethereum and some of these smart contract-based protocols. And really they see this as a new data structure with a compute element to it. So not to simplify things too much, but really it is just a ledger, a write once, read many times ledger, like a T account in accounting. And this ledger has two unique characteristics. The first is that it's distributed. So much like an Excel aligned spreadsheet or a Google Doc, when an update is made to the ledger, all the participants in the network that have a node, all the participants in the network that share access to that ledger, their nodes get updated. The second characteristic is that it's cryptographically immutable, which means in order for me to make an update in cell A1 in the sort of make an update into the ledger, all the participants in the network must agree that that entry is true or authentic. And that's done through a process called consensus. It's done through the use of cryptography, a cryptographic algorithm. Now, depending on how much you trust the counterparties that are sharing that ledger with you, that cryptographic algorithm can be on a spectrum of difficulty. It can be on a spectrum of how burdensome it is to resolve. the public networks where there's a complete lack of trust. I don't know if you're the Bank of Iran or if you're my mother that I'm exchanging Bitcoin with or Ethereum with. They use an algorithm called proof of work. And then for enterprise use cases, we tend to trust our counterparties a little bit more. We don't completely trust them, but we don't mistrust them necessarily. And so there are alternative consensus algorithms that can be used, proof of authority, proof of stake, and the like. But the general consensus is this is a ledger, it's distributed, and it's cryptographically immutable. That's what makes it special. While he's trying to figure this out, I'll just talk from memory. So when these customers came to Azure and they wanted to build these new applications with us, we looked across the hundreds of applications that we've built already with them, and there tended to be a pattern of the sorts of things that customers wanted to do with this shared ledger amongst multiple companies. It tended to be, I have an asset. That asset could be physical. In a supply chain, it could be financial. It could be a financial security. Or it could be a tokenized digital representation of an asset, a digital IP. But if that asset is moving across organizational boundaries with a requirement for audit, so I want to go back and understand the terms under which that thing moved or changed state, or dictate the terms under which it is allowed to change state with a smart contract, then the blockchain becomes this really interesting shared data layer to track the movement of that asset. Basically, I would say the majority of the use cases early on that we saw were really event-driven sort of state machines, where the blockchain was acting as a shared data layer to govern the movement.
But the key point was they was immutable, is that correct?
Exactly, yeah. Okay. So you could think about, I think we have a use case slide coming up here in a second. That asset can be anything. In the case of 3M, they cared about high-value pharmaceuticals. They cared about, they were working with pharmaceutical companies that wanted to make sure, immutably, that the pharmaceutical was not being tampered with by people in the supply chain from the lab to the retail pharmacy. And if you think about what those pharmaceutical companies do, there's a tremendous amount of risk in managing that supply chain. And there's a lot of overhead in sort of double checking, triple checking, reconciling, making sure that everything hasn't been messed with. Because if grandma's medicine gets messed with, then people get sick, and they're at. Oh, look at that.
Yeah, but it's the wrong way.
You get to see all my speaker heads.
How many engineers does it take to present this slide?
So with the blockchain, what 3M was able to do and do in concert with the pharmaceutical companies was codify the things that they were concerned about. What are the risks that you're concerned about? I want to make sure that that the inputs to the pharmaceuticals are what I think they should be. I want to make sure that the people that are touching the box have the right credentials. I want to make sure there's a number of things, and they say, how can we get an immutable input or an immutable attestation stored to the ledger that the right person or the right action is being taken at the right time. Again, it's really just a state machine.
Was it also crossing state boundaries, so you had customs and all that stuff?
Exactly. So you'll see a lot of the partners that we have worked with are Ernst & Young, they're PwC, former audit firms that are offering advisory services for everything from tax and customs and border
attestation.
Exactly.
Cases, basically.
You can do the same thing with GDPR. I get a GDPR. There's a company that we work with called GDPR Edge that is, they wanted to make sure that they had an attestation store to provide to regulators that GDPR requests were being complied with. So they would get an attestation. They set up a state machine where a customer would say, hey, Target, I want you to forget everything about me. Every point of sale I ever used, every website I ever visited, every coupon I ever used, every email you ever sent me, I just don't want you to ever know that I existed. So GDPR Edge has a data lake. It will collect the complete profile of who you are, click delete, and then they give an attestation that says, I received a request, I acted on the request, here's how I acted on it, and here was the current letter of the law for GDPR at that time. Yes, I'm in compliance, check, and then you have that highly immutable audit log that you can show to regulators.
Can I ask one technical thing? What are you using as the blockchain technology underneath? I mean, are you using Ethereum or?
It depends on the use case. So
Okay.
I think I think one of the things that we've learned early on was that there is no one-size-fits-all ledger.
Okay.
There's each ledger has a different approach for different things, for privacy, for permissioning, for confidentiality, for throughput. They use different consensus algorithms. And so we sort of meet our customers where they are. We're very open, but I think we're opinionated. Right? So Corda is one that we find our financial services customers use quite a lot. It was built by bankers.
Right.
Ethereum is a great general purpose ledger, and it has a massive developer community, and it has a variety of consensus algorithms that you could use. Quorum has a different one, Parity has a different one than Pegasus, and so we find that there's a big developer community in Ethereum, and so there's a lot of activity in that with that ledger. Fabric is another good one we're introducing. Actually, Fabric 1.3 in Azure tomorrow. Don't tweet that out, but yeah, I think it's tomorrow, Thursday. And for use cases where your counterparties are relatively static, so the counterparties I'm sharing the network with don't really change that much, they're not dynamic, then the channel approach works really well. When the counterparties are coming sort of in and out, they're changing, the terms are changing, and then it becomes like Slack. It becomes like this really long, difficult, unwieldy thing to manage. So that's not always necessarily useful. But to answer your question, let's see if I'm understood.
Thank you.
Are we back? This is a good one to go with. So when we started building these applications, I think what we found was that the ledger was really just a point of departure. We first made it really easy to deploy the ledger into your Azure subscription, whichever ledger you wanted to use. And then quickly we found that customers were building an application. Applications is something Microsoft has been building far before blockchain, far before Azure. And enabling software developers to build applications is kind of our bread and butter. And so we thought, what are the difficulties of building this unique new type of application? And what we found is that what the sort of yeoman's work of blockchain is taking your state machine and parsing it into a JSON file, building a smart contract, learning Solidity, and figuring out how to codify the logic of how your business interacts with other businesses. How do you do a bean to barista workflow and define that entire state machine and all the terms for, or a farm to fork scenario, or whatever it may be. That's what we wanted developers to be focused on. What we found is they were spending 80% of their time on infrastructure scaffolding. So they were, how do I deploy the ledger into my network? How do I associate Active Directory, federated identity for each of the companies that have a node on the network? How do I ingest messages from an IoT device that's relevant for my smart contract if I care about the temperature and humidity of this thing that's on the truck and I need an attestation for that? How do I transform that message into a format that's expected by the blockchain's native API? How do I build and sign and route transactions and sign them with keys stored in something like Key Vault? What if I want to pull ledger data off of the ledger and into a store like Cosmos or SQL, a database that most people in my organization know how to use? I can't query the blockchain directly, but I want to know what's going on. How do I make those connections? And importantly then, how do I do the messaging and the integration such that I can send whatever I care about, to Chris's point, whatever it is I care about the immutability of, I need to have immutable data on the temperature, humidity, or the GPS location of foo asset. What am I going to go do with that? Well, I'm going to go take an action in an ERP system. Making that connection between blockchain and those systems of record was taking a lot of time. So we spent a bunch of time with developers and customers saying, what you really should be focused on is the smart contract, and we can take care of a lot of the infrastructure stuff.
Quick question about
Sure.
the GDPR compliance.
Yes.
If the ledger is immutable, then how can you delete records through access controls, or how is something removed if it's immutable?
It's a great question. The recommendation is don't put GDPR data on the ledger. For the GDPR solution that I was talking about earlier, the actual PII data is not going on the ledger. It sits in a data lake that Target or any other retailer or whoever it might be has. And the only thing that's going on the ledger is the attestation that I complied with different parts of the state machine. Attestation that I received your request on X date. Attestation that I took X action within a certain range of time, attestation that the action that I took is in compliance with the current GDPR record. I can hash, the letter of the law as of XYZ date. So you're putting hashes onto the ledger, but you're not putting any sort of personal data on there. But it's a good question. So at Build, which is our big developer conference in May, we introduced this offering called the Azure Blockchain Workbench, which the goal of this was to take the time that it takes to build an application on blockchain from several months and several $100,000, which is honestly what it was taking most of our customers, to just a couple of days. With a few simple clicks, you can deploy a ledger into your Azure subscription and the Azure subscription of your counterparties, pre-integrated with a set of Azure services you need to build that application. Active Directory for identity, Key Vault for storing public and private keys, off-chain data. And the goal of this really was just to accelerate the development of these applications, and for us, quite frankly, to learn. We had several hypotheses about services that we could introduce to make developing easier, but they weren't high fidelity enough hypotheses, and so we didn't want to spend 2 years testing. We said, let's put a tool out there that can help people go 80% of the way, and we'll get feedback on where people are running into walls, and then we'll assess that feedback and go for a problem. So it does a couple of things here. At the bottom, it enables you to choose, like I said, the ledger of your choice, the ledger that makes most sense for your use case. It integrates that ledger network with the set of Azure services here in the middle that you would need to build a blockchain application. And then it integrates those with the systems of record that you would be using today to manage your work. Building a blockchain application is hard enough as it is. You shouldn't have to rip and replace your ERP system. That's way too ambitious. So it's got to work with what you have. I think the other thing that we found as customers were building with this is, while it is a developer tool, ultimately you have to show this to business decision makers. You have to show this to the people that own supply chain, or that own the supply chain in concert with people upstream and downstream of your company. And you can't evangelize a new solution with a code-based UI. I mean, it couldn't look like the Matrix. We needed to make it look like, you needed to be able to see your business logic in the application. And so we spent a bunch of time thinking about what's the thing that you need to be able to visualize, and we put a lot of effort into this sort of smart contract management UI. It really simply allows you to see. You can see here you have Active Directory integration, so you can see the counterparties of your smart contract are the Skype address and the Skype ID of me, really.
In your traditional applications, when we'll do a lot of testing, how do you do testing in this environment?
We've written a great paper with Azure DevOps, Visual Studio, and Truffle, which is an open source Ethereum company. They're a consensus spoke on DevOps for smart contracts, basically. And I can send a link to this group or to you.
Please do.
Share, but,
Please do.
it's a big question, and we've got a lot of thoughts about it that we're codifying, I think, over time with the help of people that think about DevOps really, really deeply. The last thing, I don't know how much time I have.
Still got 12 minutes.
12 minutes, all right. The last thing I'll say, I think, is the Workbench tool was simple by default. It was meant to sort of templatize a bunch of services so that customers could model smart contracts really quickly and really easily. We didn't expect it to move quite as quickly as it did, but soon developers were like, I want to go do this, I want to go extend this, I want to build more robust applications. And their requests were typically in 3 areas. One is, I have to be able to connect heterogeneous interfaces to this thing. I have to be able to ingest messages. My smart contract for my farm to fork scenario is my smallhold farmer in, outside of Lagos needs to be able to send an attestation that he received delivery or he put something on the truck, but he uses a feature phone. I need to be able to ingest messages from SMS. Same thing with IVR. Same thing with, there was a lot of financial services use cases where people were sending data back and forth to one another using flat files, FTP. It's just, this is the nature of how this multi-party workflow works today, and I need you to help me interact with it today. So connecting interfaces was one big area. Integrating with sort of a broad set of data and SaaS consuming services. So I need to be able to send and receive hashes and send and receive data from OneDrive, Google Drive, SQL, Cosmos, MySQL, open source databases, and I need to be able to send messages for triggering action to SAP, Adobe, Dynamics, you name it. So to address these two big issues, we partnered with our logic apps and functions teams. So these are teams that think deeply about serverless technologies and messaging. And we created a really elegant logic app connector that allows you to read and write from the ledger. Ethereum is the first one that we wrote. We have one working with our partners at Corda right now. We're working on Hyperledger Fabric. But the idea is that you should be able to, no matter where your data messages are coming from, you should be able to really quickly, in almost like a wizard format, ingest those messages and write them to whatever chain you need to. The third big thing is exactly the point that you brought up, was DevOps. It was, I built this application, how do I do testing?
Yeah,
How do I manage versioning of smart contracts?
It's the testing which is really going to get people, because particularly when you've been taking it from 10 to 5,000 transactions to 75 to 100,000, we're dead.
Yep. We have there's a guy on our team called Michael Blaros. He's worked on two of our biggest sort of consortium applications. We have one with Maersk and a constellation of insurers and reinsurers and brokers that underwrite the cargo that is being shipped on Maersk, on 800 Maersk vessels at the moment, but we're expanding it to other lanes. But essentially what they wanted to be able to do, the Maersk folks said, why are these insurance premiums so high? And the insurers said, because I have no immutable data on the risk that this cargo was under while it's en route. I don't know if you're wading into international waters or wading into a storm to try to shave time off and it's putting my cargo at the edge at risk of falling off. I don't know if you're trying to save money on gas and you're keeping the stuff at the wrong temperature. I don't know how fast you're going into port. I don't know any of this stuff. And it takes me 6 months after the fact to go back and reconcile that. That's a huge cost for me. So until you have a better way of showing me that my cargo that I'm writing this insurance premium on is actually safe, then I'm going to continue to charge these onerous premiums. And so what we find with all of these applications is if you can find sort of an assumed cost of doing business, that multiple parties just sort of shrug their shoulders and say, well, this is how we have to do it. That's typically a pretty good indicator that there might be a use case for a lot of people.
Yeah.
So for this one, we had 800 vessels. I think we had 11 or 12 insurers and brokers, multiple counterparties, the contract logic for all of them, and we're doing 800,000 to 1 million transactions a year, and doing the versioning and management of those smart contracts was a huge burden, and that was a lot of the learnings that we brought in at DevOps.
Have you found people sort of adopting the Netflix microservices chaos, type theory of testing this stuff?
That might be a question for Michael.
Okay.
But I can certainly make a connection.
Okay, thank you.
So